you have limit x tending to 2, x to the power of 6 minus 64 by x minus 2. If you take 2 to the power of 6, this will become 64 and this will become 0 by 0. So listen one thing, I need to take a factor x minus 2 out of this. So what I'll do, I will use this formula directly. I just did this proof of this formula. Limit x tending to a, x to the power of n minus a to the power of n upon x minus a gives me n a n minus 1. I'll just use this formula here. So this is, I write this in this manner. So limit x tending to 2, x to the power of 6 minus 2 to the power of 6 upon x minus 2. Now this is in this format. The answer is 6 into 2 to the power of 6 minus 1. 6 into 2 to the power of 5. This is 6 into 32. This is 32. And this comes out to be 18192. This comes out to be 192. Now the application of the binomial theorem that I did right now to find this type of question. See why I need that. Why I told you all that. Now see this. Take a question like this. Limit x tending to 0 under root of fourth root. This is the fourth root of 1 plus x. This is minus 1 minus x upon x. Now if I put x equal to 0, this will be 1 and this will be 1, all will be 0, 0 by 0. So I need to expand my binomial. This can be written as limit x tending to 0, 1 plus x to the power of 1 by 4 minus 1 minus x to the power of 1 by 4 upon x. Now see, this is like n, this is behaving like n, this is a, this is b, this is a minus b, and this is n. So exactly now I'll do that only. Limit x tending to 0. Now I'll expand this 1. This will be 1 plus 1 by 4x plus 1 by 4 into 1 by 4 minus 1 upon 2 factorial x square. Now this will be plus 1 by 4, 1 by 4 minus 1, 1 by 4 minus 2 upon 3 factorial by x cube and so forth. Keep this in bracket. Now let's write the minus 1 here. Now the minus 1 will be 1 minus 1 by 4x plus 1 by 4 into, wait a minute, let me write it in small, plus 1 by 4 into 1 by 4 minus 1 and x square, and then it will be minus, I have to shift it a little bit this side. Wait a minute. I need to shift it a little bit this side. Wait, yes. Now it's okay. Now you can see this. Wait. Then I can write minus 1 by 4. Wait a minute. Let me write it here properly. Yes. Minus 1 by 4, 1 by 4, minus 1, 1 by 4, minus 2 upon 3 factorial upon x cube and so forth. Now I have this x in the down. Now let's see this. The whole thing. This is here for you. Yes, you can see this. Now this will become limit x tending to 0. Open up the things. Wait a minute. There was some mistake here. Wait, yes. This bracket should come here. Yes, now it's okay. And this should be blocked off because of the shifting things little became. Now 1 minus 1 will cancel. Minus will become plus, and then this will become 2 by 4 x. This and this x square term and x square term will cancel out. This will be minus and minus plus 1 by 4. This will be 1 by 4 and 2 here. 1 by 4 minus 1, 1 by 4 minus 2 into x cube it is, sorry. Into x cube it is. Just a minute, because of that shifting, there was some problem. This is x cube. So this will become x cube and the odd terms will be here upon x. Now do one thing, cancel all the higher order terms of x cube, x5, x7 will be here. So cancel this with this. This will become square. They will be higher order terms. Take the limit. These all terms will be 0. Don't calculate. These all terms will be 0. The rest all terms will be 0. So what you will get is 2 by 4, and that is nothing but half. I hope you have understood this point. Now we will do limit at infinity. This is also a very good topic. Limit at infinity. This is the sixth topic, I hope so. Limit at infinity. Limit at infinity. Let's understand what I mean by this. See, 1 upon, see, x, if this is, x is infinity, this will give me 0 basically. That's the idea. Now see, let's do limit at x tending to, say, let's understand this way. 0 plus 1 upon x. This will give me 1 upon 0, and this will give me plus infinity. See, this is your 0, this is your 0 plus, and this is your 0 minus. So this is basically, let me explain this clearly. Wait, see, this is limit. I'm explaining this. X tending to 0 plus 1 upon x is something like this. 1 upon 0.0000001, and therefore it is coming out to be almost be 0. So this is coming out to be 0, infinity. I hope you got this explanation. Let's see the next explanation. Limit x tending to 0 minus 1 upon x. This will be somewhere here in this place. This will be minus 0.0000001. This can be written as minus 1.0.0000001, whatever I have written. And this is almost 0. So minus 1 upon 0. This comes out to be minus infinity. Keep this thing in your mind. Now, this is one thing. Now, let's see. This is very, very important. Keep these two things, results in your mind. At x plus 0, this becomes plus infinity. At x minus 0 minus, this becomes minus infinity. Keep this thing in your mind. Now, the next part is that I need to tell you. Wait. Yes. Let me take it this way. Now, see. Let's take two fractions. Limit. I told you that before only. I should have told you later on. Now, see. Suppose this is my 1 upon x. This will be 1 upon infinity, and this is going to be 0. Let's first take an easier examples. X infinity, I have an x here. There is nothing in this. This will give me infinity. Suppose I have like this, limit x tending to infinity. I have an x and an x. I'll get 1 because the power of this and this are same. Here the power of x is more. Here the power of x. 1 means x to the power of 0. Here the power of x is more, and here it is x. 1 means here and here. This 1 means this, and this 1 means x to the power of 0, basically. Nothing more than this. Okay, fine. Now let's do with some more example. Let me tell you the actual type of examples that you need to understand. Now you take this type of question. Limit x tending to infinity. You have 3x square plus 5x plus 7. This type of quadratic equation you have seen in your smaller classes. 4x square plus 4x plus 9. See, both have the same power. So the answer will be, if you want to do it directly, it will be the coefficient of air and the coefficient of air, that is 3 by 4. But let me tell you how it is, how this has come. See, limit x tending to infinity, divide by x square both sides. 3 plus 5x upon x square plus 7 upon x square upon 4 plus 4x upon x square and 9 upon x square. Now if you take the limit, this 2 will cancel with this will cancel with this. This will be 3 plus 5 upon x limit. 1 upon x limit is sorry, I made a mistake. This is to be infinity. Now 5 upon infinity is 0. 7 upon infinity square is again 0. And 4 plus 0 plus 0, because limit, I told you, x tending to infinity, whether it is 1 upon x or it is 1 upon x to the power of n, whatever type, it will always give 0, because it will be 1 upon infinity is 0. This is the reason. Now, see, the coefficients are both, powers are both same here. So you just write down the coefficients directly this way. Now, देखो इन दोनों का पावर सेम है, दोनों स्क्वायर स्क्वायर है. इसका कोएफिशिएंट 3 है, इसका कोएफिशिएंट 4 है. 3 और 4 इसका होगा. क्यों होगा? ऊपर और नीचे दोनों न्यूमरेटर और डिनोमिनेटर को x स्क्वायर से डिवाइड करो. पूरा x स्क्वायर सोचो तो यहाँ पे 3 रह जाएगा 5x अपॉन x स्क्वायर 7 अपॉन x स्क्वायर एंड दिस विल बी 4x अपॉन x स्क्वायर एंड 9 अपॉन x स्क्वायर ये x और ये x स्क्वायर कट के 5 अपॉन x रह जाएगा 7 अपॉन x स्क्वायर 4 अपॉन x 9 अपॉन x लिमिट एक्सटेंडिंग टू इन्फिनिटी पे 1 अपॉन x हो चाहे 1 अपॉन x टू द पावर ऑफ n हो हर समय अगर n पॉजिटिव हो तो हर समय ये जीरो देता है इफ n is positive x to the power of n and n is positive this will give you 0 that's the reason now take one more example limit I take this type of an example only 3x to the power of square plus 7x x plus 8 I have nothing to do with this limit extending to infinity I have 4x cube plus 7x plus 8 now see the power of the denominator is more here and the power of the numerator is less so divide both sides by the answer will be 0 why now you see limit x tending to infinity divide by the highest power in the numerator and the denominator this will be 3x square upon x cube 7x upon x cube 8 upon x cube here it will be 4 7x upon x cube let's make it 6 for some difference yes 6 plus 8 I made it 8 let's make it 9 in both let's make the digits different 9 upon x cube this will become x square this will become x and this will become x square now take the limit this will be 0 plus 0 plus 0 upon 4 plus 0 plus 0 so this answer is 0 that's why अगर नीचे वाला polynomial का पावर ज्यादा होगा तो 0 आएगा आंसर if the polynomial in the denominator has higher power it will give a 0 answer this is the point you need to note now the next is limit x tending to infinity suppose now it is 3x to the power of cube plus 4x plus 7 and you have 2x square plus 7x plus 9 so now the power of the numerator is more so the answer will be infinity nothing else why check because you cannot cancel this power you cannot cancel this power now see you divide by infinity on both sides x cube by both sides 3 plus 4x square 4 4x upon x cube plus 7x cube then you have 2x square upon x cube then 7x upon x cube plus 9 upon x cube now this will become square this will cut and this will become power square this will cut and this will become x so this will be x plus 0 plus 0 and here it will be 0 plus 0 plus 0 which is undefined and this is infinity that's the main reason अगर ऊपर वाले का पावर ज्यादा हो पॉलिनोमियल का नीचे वाले का पावर कम हो पॉलिनोमियल का आंसर इन्फिनिटी होगा if the power of the polynomial highest power of the polynomial in the numerator is more than that in the denominator you will get infinity straight away with this now let's see some important points that I need to tell you wait now let us see we already know I told you summation n is nothing but 1 plus 2 plus 3 up to n this has a formula n plus n into 2 summation n square that is 1 square plus 2 square plus 3 square up to n square this is n plus 1 2n plus 2 n plus 1 by 6 and summation n cube 1 cube 2 cube 3 cube and so on and so forth n cube this has a formula wait a minute this has a formula n into n plus 1 by 2 whole square just the square of this now supposing you have this thing now you have this thing summation 2n minus 1 that is 1 plus 3 plus 5 plus 7 up to 2n minus 1 so this will give me n cube that's it now let's do a problem using this thing keep these 4 points just a minute keep these points in your mind this 1 2 3 and 4 this all points now we will do a question on this now limit n tending to infinity summation n cube upon 2n to the power of 4 plus 3n. Now summation n cube, n into limit, write down limit n tending to infinity, n into n plus 1 by 2 whole square upon 2n to the power of 4 plus 3n. Now don't open the square, see the trick, what to do. Limit n tending to infinity, take this n out, this one n out. This n will come out, this will become 1 upon 1 upon n, and this will be whole square, and this is square and this square, and the square will happen. Now see what is happening. See, wait, let me rub this all. Now this is like this, by 2 whole square on the top, and in the denominator you have 2n to the power of 4 plus 3n. Now you write this as n square, and there is a square on the top. This will become n4 by 4. This will become 1 plus n whole square, limit n tending to infinity. Now you have 2n4 plus 3n. So n4 is in the numerator also, n4 in the denominator also, to divide. So by n4 both sides, numerator and denominator, I mean to say. N4, yeah, just a minute, yes. Now you write limit n tending to infinity. So this n4 and this, wait a minute, don't cut it right now. Wait, let's not cut it right now. This is n4. Let's not cut it right now. This is n4 and n4 by 4, 1 plus n whole square. Take n4 out of it. N4, 2 plus 3n by n4. This n4 and this n4 cancels out. Limit n tending to infinity, 1 by 4, 1 plus 1 upon n whole square upon 2 plus 3 upon n cube. Now take the limits. This will become 0. This will become 0. So this will be 1 by 4 upon, wait a minute, this will be 1 by 4 by 2, and this will be 1 by 4 into 1 by 2. So this will be 1 by 8. Next question we will do. Before that, we will understand APGP, arithmetic progressions and geometric progressions. Suppose this is your arithmetic progression, AP. Now you already have seen in class 10th A plus D, A plus 2D, up to so when A plus n minus 1D. Sorry, A plus n minus 1D. This is the last term. Now the sum is n by 2. You already know 2a plus n minus 1d. That becomes n by 2. A, you can write this a plus n minus 1d. And this is nothing but the last term. That is n by 2. A plus the last term. This is for AP. Now let's come to GP. This you already seen in class 10th. I am doing all this for those people who didn't have maths in their 11th and 12th, and they have joined BCA of GGSIPU. Now see GP, geometric progression, AR. Okay, before that, let me tell you one thing. Before I do this, let me tell you one thing. Let's go back. Just a minute. Let's go back. Let's go back and tell you something important. Let's go a little bit back. Yes, here you can see this is the first term. This is the first term. This is the second term. So D, the common difference. D, the common difference. Common difference is nothing but the second term minus the first term, which is equal to third term minus the second term, and so on and so forth. You know this already. Have seen this in your class 10th. So because I want to use this type of a thing here. Wait, let me pull it down. Now we are doing GP. Wait, we will be doing GP. Now see, in GP, geometric progression, we have AR square. This is the third term. This is AR n minus 1. Now the sum. Now see, common ratio. R is the common ratio. R is the common ratio. And it is nothing but second term by first term divided by third term divided by second term, fourth term divided by third term, and so and so. Sorry, third term, and so and so forth. So The sum is A 1 minus C. This is n minus 1. Na? This is 1 more n upon 1 minus r for mod r less than 1, less than equal to 1. Mod r less than 1, sorry, not equal to 1, less than 1, sorry. And now, and this is, now wait a minute, yes, here s is equal to a r to the power of n minus 1 upon r minus 1 for mod r greater than 1. And uh, yes, for s infinity, suppose n goes to infinity, let me write it in this side only, here, let me write it here. For this, with this condition, s infinity, sum of infinite terms, this is sum of n terms, this is sum of n terms, this is also sum of n terms, but sum of infinite terms with this condition in hand becomes a1 minus r, because this quantity goes to 0. But in this condition, with this condition in hand, if n goes to infinity, because this is r is greater than 1, this goes to infinity. That's the point. But the point or not, this is the most important thing we need. This is the thing we need always. So let us understand what do I mean by this interval and what do I mean by this interval. Let us understand. See, I have already, that's why I told you function and everything. See, if I write mod r less than 1, that means what? Mod r means what? You know mod r. Mod r is nothing but r less than 1 and minus r less than 1. Why? Mod r is written like this for r greater than equal to 0, minus r for r less than 0. I hope you remember this modulus function. Now r is less than 1. When you change the multiply with inequality, जब तो माइनस से इनइक्वालिटी माइनस से मल्टीप्लाई करोगे तो ये क्या बन जाएगा? r greater than minus 1. तो ये क्या बन जाएगा? दोनों को ज्वाइन करके r less than 1 and r greater than minus 1, मतलब ये तुम्हारा इंटरवल, अगर this will become r greater than minus 1 and r less than 1. So the interval is r, open interval. Now suppose this is your 1 minus 1 and this is your 1 and this is the open interval here and here. You will be here. You will never be here. You will never be here. This means that. This condition means that you are inside minus 1 and 1. And suppose I write this mod r less than equal to 1, then I mean you will now include 1 and minus 1. In this will now become closed interval. You will be here, never here and never here. I'm talking about, I'm not using this equal to in this formula above. I'm just telling you what does this mean. What does this mean in an interval? This is an interval from minus 1 to 1. Similarly now if I tell so, look here. So if I say, this, I discuss about this r greater than 1. So you already know what is r. R is greater than 1 or r is greater than 1 or minus r is greater than 1. So r is greater than 1 or r is less than minus 1. Let us take the interval 1, minus 1 and 1. Now either r is greater than 1, this side, or r is less than minus 1, that is this side, but never this side, never this side. Earlier, these two sides are possible. Earlier, see the diagram. See the difference. Just a minute. See the difference in the diagrams. Here, everything inside. Here everything outside. This is the only difference. So now we will, I think you have understood this concept. If you have not, repeat this. मैं ये बोलना चाह रहा हूँ, अगर r less than 1 है तो वो इंटरवल के अंदर रहेगा, r greater than 1 है तो वो इंटरवल के बाहर रहेगा, जो भी कुछ बाहर है, this side or this side. If r is less than equal to 1, it will be inside the interval and nothing outside. And if it is r is greater than 1 here, then everything will be outside here and here, but nothing inside here. Nothing will happen. It will not be inside the interval. Okay. Next, let's come to use this concept to do a problem in limits. Now see, question, I don't know why this is coming, wait. Question, limit n tending to infinity 1 plus 1 by 5 plus 1 by 5 square plus so and so forth 1 by 5 plus 1 by 5 to the power of n minus 1. So already you know what is a. A is 1. AR is 1 by 5. So undoubtedly R is 1 by 5, which is less than 1 from the conclusion. Now comparing, now see, I need S infinity is what? Because I want to put the limit at the end only. So let's not put the limit right now. Let's write Sn. Let's write Sn first. Sn is a is 1. What is the formula? S is equal to a 1 minus r to the power of n upon 1 minus r for mod r less than 1. So, say 1 by 5 is less than 1. So that's why this formula. A is 1. No need to write the 1 minus 1 by 5 to the power of n. Now 1 minus 1 by 5 according to this formula according to this formula. Now I told you this will now, see, this will now, I told you this is 1 upon 5, and at n tending to infinity, this will go to 0. This quantity will go to 0. This quantity, whole quantity will go to 0. Why? Let's see here. Let's see here. क्यों ये quantity पूरा 0 क्यों हो जाएगा? देखते हैं यहाँ पे. Look, let's roll it down. Yes, now see. See, 1 by 5 to the whole to the power of n can be written as 1 by 5 to the power of n. In the limit n tending to infinity, this quantity will become 1 upon infinity and hence 0. So that's why this will become 0. So limit n tending to infinity, Sn, is 1 minus 0 upon 1 by 5. So this becomes 1 upon 4 by 5 and this becomes 5 by 4. I hope you have understood the concept. देखो 1 upon 5 to the power of n है तो उसको कैसे लिख सकते हो? 1 upon 5 to the power of n tending to, एक सेकंड यहाँ पे जरा ठीक से लिख देता हूँ, is limit n tending to infinity. तो ये क्वांटिटी पूरा infinity बन जाएगा. This quantity will become infinity. 1 upon infinity क्या हो जाएगा? 0. That's why 1 minus 0 and 1 minus 1 by 5 is 1 by 4 by 5, that is 5 by 4. Now, next type of questions. These are good questions. Now, yes, now I think I can give you one question. You can do it on your own. Try to do this question or I'll do this. Okay, I'll do one, you do the other one. I'll do one, you do the other one. Now here it is given that, question is given that limit fx, question, fx is given to me ax plus b upon x plus 1. In limit x tending to 0, fx, I am getting 2. And in limit x tending to infinity, I am getting 1. So they are asking me what is the value of, now I want to find the value of a and b, find a and b, and hence find limit x tending to minus 2 fx. You have to find this limit. Now here the problem is very simple. What you know, क्या दे रखा है देखते हैं. यहाँ पे दे रखा है एक fx x फंक्शन दे रखा है, लिमिट एक्सटेंडिंग टू 0 पे 2 है, इन्फिनिटी पे 1 है. ए बी ढूंढ के निकालना है, ए की वैल्यू क्या है, बी की वैल्यू क्या है, और लिमिट एक्सटेंडिंग टू माइनस 2 क्या है वो दिखाना है. देखो नाउ limit given already extending to 0, fx is 2, and given limit x tending to minus infinity, sorry, extending to infinity is equal to 1. Now just put the values, just let's write it down now. Let's write it down. Here it is. Yes, this is 2. Now this is ax plus b upon x plus 1, limit x tending to 0 is 2, and here limit x tending to infinity, ax plus b upon x plus 1 is equal to 1. Now 0 you put here, so this will become 0 plus b upon 0 plus 1 is equal to 2. Therefore b from here comes out to be 2. Now I told you if both of them have the same power in a polynomial, just write the coefficients. So this will be a by 1, or you can, if you want, you can write that this way also. Wait, limit x tending to infinity, divide a by b by x, 1 upon 1 by x, and you have 1. Take the limits. A plus 0, 1 plus 0 is equal to 1, implies a is 1. A and b I have found out. Now I need to find this term. I need to find this. Where is it? This one. I need to find this quantity. Now. See here. This quantity I need to find. Limit x tending to minus 2. I have a as 1. I have a as 1, x plus 2 upon x plus 1. Now I want to find my, if I put minus 2 here, this is not becoming 0, but the above one is becoming 0. So no problem. See, देखो ऊपर वाला तो 0 बन रहा है, नीचे वाला 0 नहीं बन रहा, नीचे वाला बन रहा है माइनस 1, नीचे 0 नहीं बन रहा है, तो फिर कोई प्रॉब्लम नहीं है. 0/0 हो जाए तब प्रॉब्लम आती है. तो नो प्रॉब्लम. लिमिट पुट कर दो, सीधा सीधा डायरेक्टली लिमिट पुट कर दो. -2 + 2 upon -2 + 1 and we'll get 0 - 1. Answer is 0. Now the question that is for you is limit x tending to 2 ax square plus b, sorry, ax square minus b, ax square minus b upon x minus 2 is equal to 4. Find ab. Find a and b values. You have to find. Now see one thing. In this case, you need to be very careful how to find the value of a and b. Let me do this problem for you. This will be a bit tricky for you to understand. Wait, let me do it for you. Now here you have this question, ax square b. Now what you do is that so if you put 2 here, there is a problem. If you put 2 here, there is a problem. Then the lower one will become 0. Lower one should not become 0. I need to get rid of this under x minus under root 2. I need to get rid of x minus under root 2. So I cannot, I mean, rationalize here. Again, it will become 4 minus 4. That won't help the job. That won't help at all. So they say this limit is 4. Now, so, and 2, at 2 there is a 0 here. 2 this is 0. I have to make this also 0 in however sense, this up numerator, 0/0 form. So, what I do is that, मेरी बात नहीं समझ में आई. यहाँ पे ये 0 तो बन रहा है, अब यहाँ पे मुझे मालूम नहीं 0 बन रहा है कि नहीं बन रहा है. ऊपर कुछ भी हो, नीचे 0 हो, anything is on the, any number other than 0 is here in the numerator, but something 0 is not acceptable. Either you make them both 0, 0. So I need to make them both 0, 0. What I do, see, I'll try to make them both 0, 0. How to make them both 0, 0? See, limit x tending to 2, you take a out, x square minus b by a upon x minus 2 equal to 4. This is a trick. See, मेरा टारगेट है, ये देखो यहाँ पे अगर मैं यहाँ पे ऐसे पुट करता हूँ x square minus b over x minus 2, यहाँ पे अगर मैंने 2 पुट कर दिया तो कुछ भी ऊपर होगा 4a minus b by 0. दिस इज नॉट एक्सेप्टेबल. इसको भी मुझे 0 बनाना पड़ेगा, ऊपर वाले को भी. तो इसलिए मैंने a को कॉमन लिया. अब देखो लिमिट x tending to 2 a x minus this is a square b square, this is under root का whole square ले लो इसको, तो x minus under root b by a and x plus under root b by a by x minus 2. this should is 4. तो देखो इसको, ये फैक्टर को भगाना है. दैट मीन्स दिस फैक्टर under root b by a must be 2. Otherwise I won't be able to put the limit at any cost. I have to have under root b by a equal to 2. Otherwise I won't be able to cancel the factor. देखो ये फैक्टर को अगर कैंसिल करना है तो इस चीज को, इस अंडर रूट बी बाई ए को 2 होना जरूरी है. सो इसको मैं मानूंगा लेट in order to, wait, let me rub all this, otherwise you will think what I have done with this. Now let me select x minus 2 has to be a common factor in both the part. So let's write it down. So x minus 2 को मुझे रिमूव करना है. दिस x minus 2 को रिमूव करना, दोनों तरफ आना चाहिए. x minus 2 is a common factor. So x minus under root b by a is same as x minus under root 2. I have to take this. So therefore what I'll get is under root b by a is 2 and under root, whole under root, sorry. This is whole under root b by a is 2. Whole under root b by a is 2. So under root b is equal to 2 under root a. This is one thing. Now we have this thing. See, we have this thing. Now I need to write. Now what I'm left with? If I take this if I take this equal to this, so this factor and this factor will go. X minus this factor will go and this factor will go. Now what you are left with? See. Now what you are left with? See, limit x tending to 2, you have a x plus under root b by a. You have b by, let me write it little big. Wait. You have a into x plus under root b by a of equal to 4. This you have now left with. Now put the value of this. Now you see what happens. Put the value. So now you have a into, when I'm taking, see, one condition I got from here, the next condition taking from here. Now 2 plus under root b by a is what? 2, and this is equal to this under root b by a. What I have taken? This I have taken as 2. So 2 plus 2 is 4. So a comes out to be 1. Now a is 1. Put the value of a back here. Back here. Now see what you will get. Put the value of a back here. Right? Huh. So you will have under root b is equal to 2 under root 1. That is nothing but under root b is 2. So implies b is 4, squaring both sides. So a is 1 and b is 4.